This is Precalculus lesson 3-3. Today is November 26th. So let's go ahead and write that in our top up here. It is November 26, 11/26. My handwriting is atrocious right now because I am currently bouncing my son who has the stomach flu that I am home with. Alright, so I'd also like to say welcome back, Johnny. You need to get worked into our system with Classcraft and a bunch of other things, but I will do that once I am back at school. But I appreciate that you're back. I'm sure Rochelle and Daisy are looking forward to working with you this year. Some announcements before I begin. First of all, Classcraft. This isn't as big of a deal with this class because you guys are usually so well behaved, but everything is multiplied by 2 for substitutes from now on. That means you can lose two times the HP, or you can gain twice the XP, level up faster, die faster. It's up to you. Just be on your best behavior for the substitute. Other note, we have very little time before, what is going on here? Very little time before the end of the year. So we are here on the 26th. That means we have 5 days, another 5 days, another 5 days. Here's finals. Finals are on the 18th. That means we have 16 days until finals. Finals are the 18th, 19th, 20th, and the 21st is our Christmas party. So you have 16 days to get your grade where you want it to be, 16 days to finish your missing assignments, 16 days to make up quizzes and test scores. Okay, that's all I'm going to say about that. Let's go ahead and come back to, that is not our notes, this is our notes. Alright, so we're on our third lesson on our unit. Let's go ahead and talk about the vocabulary that we already know and some new vocabulary as well. A vector. What is a vector? What two things define a vector? You should know this. I know it is a long time since we actually did math because of Thanksgiving break, but what is a vector? Think about this. Pause the video, think if you need to. A vector. This is something that has magnitude and direction. So it has magnitude and direction. Oh, that's a bad and. I'm just going to go and direction. Usually a vector is represented by an arrow, and you can see the arrow down here. This is a vector. It's just an arrow from something to something else. All right. What is magnitude? I've talked about it right here. Magnitude, you remember the definition of magnitude. It's one word. I'm pausing so you can think. And yeah, the one word is length. So the magnitude of this vector is the length from here to here, this length of the hypotenuse. If I were to draw this triangle down here, the magnitude is just the length of vector A. It's a fancy way to say length. So component form, everything that we've been doing so far is in component form. And what I want you to write down is this. It's just an X component and a Y component. How far are you going in the X direction? How far are you going in the Y direction? And you might be thinking to yourself and rolling your eyes like, Mr. Sindel, that's dumb. We've talked about this so many times. Of course it has an X and Y component. Here's the thing. In about a week, this is not going to be the case anymore. Instead of giving you an X and Y, I'm going to be only giving you a magnitude and direction, and I'm going to have you graph it from there. So there are two different forms. Just know that the first form that we're officially talking about is called component form. Alright, and today's lesson is all about scalar multiplication, so let's go ahead and define this guy. Scalar multiplication is just making the magnitude change. The direction does not change, the magnitude gets multiplied or divided. So this is changing, I cannot spell, changing magnitude. So I'm either making the magnitude longer or shorter. I can flip the direction, flip it the other direction to go kind of in the negative direction. That's scalar multiplication. All you're doing is changing the magnitude. Alright, so there's two formulas. Oh, there's a typo right there. Don't know what's going on right there, Mr. Sindel. God, get on your game. Okay, so the first formula that you need is this guy. You're assuming that k is a scalar, which is just a fancy way of saying k is a number. Just think of k as a number. Its official name is scalar because it's actually scaling the vector. It's actually multiplying by the vector. And I'm assuming that u is a vector. Remember, anything with an arrow over it is a vector. That's how we have our notation. So if I multiply a number by vector, essentially what you're doing is you're multiplying that number by the component form, which means that number is distributed into each of those parts, which means I have k times that x component, k times the y component. U sub x, this thing right here, is just a fancy way of saying the x component. This is the y component. I could have just put an xy here, but this is the official notation. Let's go ahead and simplify this as much as we can. If we wanted to explain this to a kindergartner, how do we say it? In simplified English, multiply, and maybe a kindergartner wouldn't understand what multiply means. Maybe explain it to like a third grade or something. Multiply the number to the x and y. That's as simple as I can get it. Multiply the number to the x and y, you're done. And we'll see an example problem coming up in a sec. Our first example where we use that is 1 and 2, and then example 3 I need to teach you right now. So example 3 comes from this other formula, which is the magnitude formula. So again, I'm assuming k is a scalar, k is just some number, v is a vector, and after I multiply k times v, I'm going to get to w. W is the vector after I multiply by that scalar multiplication. Alright, so w is equal to k times v. V was my original vector, I multiply by k, and I suddenly get this new thing called w. Okay, remember that these two bars, and if you forgot this, this means, this guy right here, means I'm looking for the magnitude. Oh, got some lag, come on. Magnitude. Whenever you have bar with something here in the center, that's asking for magnitude. It kind of looks like a TIE fighter if I make wings here. No, I'm not going to do that. So magnitude. It's asking what is the length of this vector. To find the length of this vector, we'll find the original length and then just multiply it by k, make sure it's the positive version of k, make sure it's the absolute value of k. Find the original length, multiply it by k, make sure it's only positive, and you're good. In fact, that's kind of what we need to say in English. Multiply, and I'm just going to abbreviate, multiply original length, GTH, Mr. Sindel, length by the number, and in parentheses, always positive. Alright, I know, my handwriting is super sloppy today, and that's what happens when you're bouncing on a yoga ball with a young 1-year-old strapped to your chest. Alright, so let's talk about the graphical representation. What is actually happening here? So if I multiply vector A, here's the original vector A. If I multiply vector A by 2, well, that means it's twice as long. So if I multiply by 2, and maybe I should come to my line tool to make it look a little bit better, that means that this vector is no longer just this vector. It's coming from here. That's one of them. And here to right there, now that's twice as long. This vector that I've just drawn right here, I'm going to call that 2a. And that's supposed to be an arrow right there. 2a. If I multiply 2a, then the length is twice as long, and that's coming from our formula right here. Our length is twice long. Multiply the number by the original length. That's why that formula makes sense. And then look over here. I'm multiplying the x and y by the k. Look what the original value of a was. A originally had this x value of 4. 2 times a means I have an x value of 8. I multiplied the x component by 2. Oh no. The original y component was 2. The original y component to get to this point was just 2. Multiply the y component by 2 and you get to 4 right here, which happens to be the new y component. You just multiply each of the components. That's why this formula makes sense. And if you don't believe me, I can show you another example. I'm going to either way if you don't believe me. What happens if I take negative a half of a? Well, if I have negative a half, that means I'm multiplying each of the components by negative a half. So my original x component was 4. 4 times negative 1/2 means I'm over here at negative 2. So I'm now going left negative 2, and originally I went up 2. Well, 2 times negative 1/2 is negative 1. So that means I'm coming all the way down here to negative 1. This is my new end vector. Comes down, oh, I should probably use a line to make this look a little bit neater. That means my new, oh no, I don't want to drag you. My new vector looks like that. And you can see here that the length used to be 1, 2 diagonals, 3, 4 diagonals. Now it's 1, 2 diagonals. I mean, that's very unmathy to say. You would normally use the Pythagorean theorem to solve for what that hypotenuse is, but you can see that it does roughly look to be half of the original length. So both of those formulas make sense in this case as well. And we can go ahead and label what we've just drawn here. This is -1/2 of vector A, arrow. Cool. All right, so let's flip to the back. I should hear papers roughly. We have 3 examples and then we're done. Yep, just making sure. All right, so example 1. I'm saying that the component form of vector v is 2, -7. What happens if I do a scalar multiplication of -5 times that vector v? And this is super, super easy. I'll show you how easy it is. You multiply -5 times 2. -5 times 2 is a -10, and -5 times -7 is 35. You're done. That's how easy these problems are. What I want you to do right now is pause the video, try to do this problem, which is a little bit trickier, but it's still pretty straightforward. It's just essentially distribution of -1/3 into each of these components. All right, so I assume that you've unpause the video because you've solved this. -1/3 times -3 is a +1. -1/3 times 12 is the same thing as 12 divided by -3, which is -4. And there's your answer. Cool, cool. Let's go to our third and final example. This is worded almost exactly like what you'll be doing on Khan Academy, which reminds me I need to add Johnny to Khan Academy, our class. So we assume that vector v is represented by some x and y. We don't know exactly what it was, but we do know that the length, or the magnitude of vector v is 8. It has a length of 8, a magnitude of 8. All right, so if vector w, I multiply each of the components by -1/2, what will be the length of w? So think about this. The original length was 8. Each of the components is multiplied by -1/2. That means that according to my formula, all the way up here, I just multiply my original vector by the number. So the number is -1/2. So multiply 8 times -1/2, that's going to be -4. The problem is length is always positive. So the answer here is just +4. You will never, 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 ever, ever get a negative answer when it's asking for this type of question. You'll always get a positive answer here. Even if it's going the other direction, the length will always be positive. The magnitude will always be positive. In fact, if you want to make that note, maybe that's kind of a red star worthy category. If you ever have something like this of x, for example, this will always be positive. Always positive. All right. What about this one? If I multiply each of the components by 3/4, that means I'm multiplying this length by 3/4. So go ahead and do that now. Pause the video if you need some time. What is 8 times 3/4? All right, 8 times 3/4 is 6. And if you need to see how to do that, I can do it really quickly over here on the side. Let's do it over here. So 8/1 times 3/4. 8 and 4 simplify to 2 and 1. 2 times 3 is 6/1, which is 6. All right. The other part of this question is doing a little bit of graphical representation. So if vector v, the original vector that I talked about up here that had a length of 8, this clearly does not have a length of 8. It has a length of a little over 4, I think. If it does have a length of 8, then what does vector w look like? Remember, vector w is now going -1/2 in each of the components, which means since this is negative, this is now going to switch directions. Remember that you can look at this at the component form level too. So this is 1, 2, 3, 4. I can write that here. 4 in the x direction and 1 in the y direction. So vector w is going to go -2 and then down 1. So it's going to look like this. Oh, I should use my line tool since I have that ready to go. So that means let's choose green. That means this vector is going to go -2 and then down 1. And then what about z? Let's do z in red. Oh, I just changed that to red. Oops, that's not what I meant to do. Okay, let's do maybe z in blue or something like that. Vector z is going to multiply each of these by 3/4. So it's not going to be quite as long as 8. In fact, 3/4 times 8 is 6. Does that really help us? Well, 3/4 times 4 is 3. So that means I'm going to go right 3. So from here, I'm going to go right 3 and then up. Instead of 1, I'm going to go up 3/4. There is my vector. All right, and that is all of the notes. So you will have to be doing these sorts of matching things, and I'm realizing now that this is actually not quite correct. And if you can see why immediately without me telling you, you can get some extra credit. But the reason that this is not correct is that it doesn't have the same direction. This should be down a little bit like that. There we go. It should be -1/2 in the y direction. I forgot about that. All of these lines need to be parallel, and that won't be a problem when you're doing Khan Academy because it's multiple choice, but they should all be parallel. All right, now it looks good. All right, so hopefully if you guys have questions, you can answer them between yourselves. I'll try to add Johnny to Khan Academy, and if he can't get added, just do a manual lookup of the assignment, Johnny. Just Google search for whatever you see on Daisy and Rochelle's computer, and that should work. All right, I'll hopefully see you all on Tuesday tomorrow.